Today I will discuss about facies of very high pressure. I will cover this topic under the following heads. First, introduction. Second, glaucophyne lawsonite facies, that is also known as Blueschist facies, characteristic minerals, physical condition of metamorphism. Fifth, basic paragenesis. Sixth, eclogite facies, introduction, mineral assemblages, mode of occurrences and origin, important reactions, evidence for the formation of eclogites at very high pressure, and lastly the conclusions. Now take up the first modules, that is introduction. On the basis of pressure and temperature, we can divide the metamorphic facies into three types, mainly facies of low pressure, facies of intermediate pressure and facies of high pressure. Miyashiro originally recognized three different facies series. First, a geolite, prehenite, pumpelite, blueschist eclogite type. Second, a typical Barrovian type characterized by green schist, epidote amphibolite, gaulite, characterized by paragenesis of kyanite, selimanite type. And third, an abukama type of green schist, amphibolite, gaulite, characterized by paragenesis of andalusite, selimanite type. The abukama type is a name after the Abukama region in Japan and is similar to the Buchan type of the Dalendian. The facies of very high pressure are listed below in order of increasing temperature and pressure of metamorphism. First, glaucophyne lawsonite facies, that is also known as Blueschist facies. Second, eclogite facies. Now, first I will take up the glaucophyne lawsonite facies, that is also known as Blueschist facies. Characteristic minerals. The characteristic minerals are lawsonite, jadeite, glaucophyne, aragonite, etc. In peltic rocks, staplermelane and fenzetic muscovite are present and biotite absent. Second, albite is rare and its place is taken by the chemically equivalent pairs quartz and jadeite, which are shown to be stable even at low temperature and high low pressure. Third, lawsonite is a characteristic instead of clinogeosite epidote. Fourth, the association of glaucophyne and lawsonite is most diagnostic rather than any of the two minerals alone. On the basis of ACF and AKF diagrams, we can observe the following paragenesis, the important basic assemblages. First, glaucophyne, lawsonite, jadeite, pyroxene, pumpelite, chlorite. Second, aragonite, amine-rich garnet, quartz, sphene, etc. Third, fenzetic, mica, quartz, chlorite, lawsonite, jadeite, albite. It is extremely deep-seated sediments. Therefore, the calcareous minerals are not present deep up to 30 to 35 kilometer. Physical condition of metamorphism. Lower temperature limit may be defined by the reaction hollandite give rise to lawsonite plus quartz, which suggests temperature about 200 degrees centigrade, carried out by Nice 1968. Higher temperature limit of the facies is indicated by the reaction lawsonite plus 2 quartz. Bivalent reaction give rise to geosite epidote plus pyrophyllite plus 6 H2O. At 400 degree centigrade 6 kilobar, 427 degree centigrade 7 kilobar. Crawford et al. 1965. Thus, the disappearance of lawsonite and appearance of epidote minerals mark the beginning of glaucophene green schist facies, higher pressure equivalent of green schist facies. Pressure condition is indicated by the following reaction. Reaction number 1, albite change into jadeite plus quartz, that is NaAlSi3O8 give rise to NaAlSi2O6 plus SiO2. Second important reaction, calcite give rise to aragonite at 300 degree centigrade 7 kilobar, 400 degree centigrade 9 kilobar. Crawford in 1972. Another reaction, chlorite plus albite give rise to glaucophene plus water at 350 degree centigrade 7 kilobar by Rover 1972. Thus, it is concluded that the glaucophene lawsonite facies of rocks are formed at 200 to 400 degree centigrade at pressure of more than 7 to 8 kilobar. Now take up the next facies, that is your eclogite facies. Introduction. Most eclogites are striking in appearance with coarse reddish brown garnet porphyroblast set in a fine to medium grained matrix of green omphacite, jadeite and diopside. Chemically, the eclogites correspond to basalts or gabbroic rocks. The critical association is omphacite pyroxene plus garnet. Omphacite is a pyroxene containing greater amount of Na2O and Al2O3 and negligible amount of TiO2 as correspond to the pyroxene of igneous rocks. Garnet is lime bearing almandine pyrope with 25 to 70% pyrope and 12 to 40% gracilorite. Beside these, some eclogites contain kyanite, anisotite, rutile, ilmenite, etc. Feldspar is absent. Mineral assemblages. On the basis of common assemblages, we can observe three types of eclogites. Group A eclogites contain omphacite and garnet. Group P contain omphacite, garnet, kyanite, and group C contain omphacite, garnet, anisotite. If you will see the triangular ACF diagram on a screen, we can observe all the three category, that is group A, B and C, on the basis of different tie lines, that is omphacite garnet kyanite and omphacite garnet anisotite. Group P eclogites, beside the assemblage of group A, these may be contain primary hornblende and geosite, that is epidote. The hornblende is sodium alumina rich variety known as borosites. The formula is NaCa Mg Fe thrice Al2 Si7 Al O22 OS twice. Group C eclogites, beside the assemblage of group A, these contain primary glaucophene and epidote. Now the next module is mode of occurrences and origin. The eclogites are usually encountered as bands or lenses in crystalline complexes belonging to the gammelites or amphibolites or the glaucophene bearing cyst. In some localities, they appear to have been tectonically squeezed into the country rocks. A pair from these, the eclogite also occur as inclusion in kimberlite and basalt or as a layers in ultramafic rocks like dunite and pedotite eclogites, thus occur in a wide range of environments. Eclogite zones as such cannot be mapped in metamorphic terrains. As mentioned already, the eclogites are rocks of gabbroic or basaltic composition. In spite of the basaltic composition, plagioclase occur in eclogites. Ascola attributed the origin of eclogite to very high pressure, which is now proved by modern experimental work. The transformation of gabbro to eclogites may be shown by the reaction disregarding FeO components. Reaction labradorite plus diapsite plus olivine gave rise to omphacite plus garnet plus SiO2. The labradorite, usually we consider the composition that is NaAlSi3O8 plus CaAl2Si2O8 plus diapsite 6CaMgSi2O6 plus olivine Mg2SiO4 give rise to omphacite, and omphacite is a complex compound that is diapsite plus zeddite, that is CaMgSi2O6 plus NaAlSi2O6 plus garnet CaMg2Al2Si3O12 and plus SiO2. The overall reaction is labradorite plus diapsite plus olivine give rise to omphacite plus garnet plus SiO2. The evidence of formation of eclogites at very high pressure are shown by: first, their high specific gravity above 3.59 centimeter cube as compared to about 3.09 per centimeter cube of gabbro. Second, the presence of kyanite and zeddite pyroxenes, which are usually present at very high pressure. Third, absence of plagioclase. Fourth, occurrences appearance of diamond in group A eclogites. The detailed work of Ringwood and Green 1966, 67, 72 demonstrate that temperature nearly 1200 to 1000 degrees centigrade respectively to transfer a quartz bearing basalt to eclogites. Extrapolation of this curve to 600 degrees centigrade or below suggests pressure of 10 kilobar or less. Some eclogites therefore originated under very high pressure and temperature underneath the earth crust and are incorporated as inclusion in kimberlite, basalt and ultramafic rocks. Other may originate within the lower part of the crust, that is, those associated with amphibolites, green schist and glaucophene bearing schist. In the latter association, the eclogites are products of water free environments, while amphibolite, green schist, etc. are formed in water bearing condition. Thus, it is evident that eclogite can be formed from basic igneous rocks under a very wide temperature range when the pressure surface a minimum value around 8 to 10 kilobar at a moderate temperature. It is important to note that H2O must be absent if hornblende free eclogite is to be originated, and only a slight amount of water may be present during the formation of amphiboles bearing eclogites belonging to the group B and C. Otherwise, eclogite will be completely transferred to amphiboles bearing rocks. This accounts for relative scarcity of eclogites compared to other metamorphic rocks of basaltic composition. Eclogites are mainly occur as a lances or a squeeze body because they are very prone to alteration. Normally, they react with water and change into green schist or amphibolite facies. That is why in nature we cannot observe eclogite, or we cannot observe very frequently as a mappable body of eclogites. Eclogites is also associated with kimberlite. Usually, it is a part of igneous as well as metamorphic, because eclogites contain also the kyanite, omphacite, pyrope bearing eclogites. That is also a type A eclogite, which is formed at very high pressure and temperature without any OH bearing minerals. These are usually associated with kimberlite because they intruded forcefully at the surface without any change. They also carry the diamond, micro diamonds, especially the pyrope is a variety also present. Within pyrope, we can see the micro diamonds as compared to others. Now, the new terms is applicable, that is ultra high pressure metamorphism and ultra high temperature metamorphism. The ultra high pressure metamorphism, where we can observe the diamonds, and usually they are also associated with ultramafic igneous rocks or with eclogites. Mainly, we can see how the association usually occur. On the basis of that, we can see, if we will see the mineralogical part, then usually the omphacite, which is a complex mixture of your dapsite plus jadeite, is a clinopyroxenes variety, and omphacite is an important mineral basically for eclogites. On the basis of omphacite, garnet, if present and plesioclase is absent, we can easily recognize in field that is eclogites. If suppose you will see the Indian examples, the Ladakh ophiolite is very important. Even in Rajasthan also, we can see the Fulad ophiolites belt, where we can see the ultramafic igneous rocks. And in Odisha also, we can observe the different ultramafic rocks. And if suppose we will see the Andhra Pradesh area, that is Vajkarur area, where we can see the kimberlites, and with these kimberlites we can observe the eclogites. Conclusion: in this modules we have discussed about the Blueschist facies, that is glaucophene lawsonite facies, and eclogite facies in detail. We have covered the characteristic minerals, physical condition of metamorphism, and mineral paragenesis with the help of ACF and AKF diagram, especially for Blueschist facies. And for eclogite facies, we have covered the characteristic minerals, different type of eclogites, origin and mode of occurrences of eclogites, and the experimental support for the formation of eclogites, especially how the quartz basalt change into eclogites at a specific pressure and temperature condition, the experimental work carried out by Green and Ringwood. On the basis of these studies, we can say that they belong to very high pressure as classified by Miyashiro Facies series. Now, the new terms, that is ultra high pressure, ultra high temperature metamorphism, is introduced within 1 decade, and where we can observe how the high pressure, ultra high pressure metamorphism and ultra high temperature metamorphism occur, and especially the eclogites comes under ultra high pressure metamorphism.